finding side lengths and angle measures of isosceles and equilateral triangles. All right, so first we need to know what an isosceles triangle is and what an equilateral triangle is. So an isosceles triangle, and I'm just going to write this at the top. So we have, I want to make sure I'm spelling that right. Isosceles triangle, and I'm going to use the symbol triangle instead of the word triangle. So isosceles triangle means that two or more sides are congruent. So two or more sides. So an isosceles triangle, and I'm not going to necessarily leave this diagram up here, but I want to try to draw it like this. So isosceles triangle, usually it has two sides congruent, and we just mark that with tick marks like this. 1 to 1 means that they are congruent. One thing that we also know, if it's isosceles, then the base angles are also congruent. So base angles are just the angle that's opposite the side. So this is the side, and I go opposite to the angle. This is the first base angle, this is the second base angle, and those are congruent. If you're given a diagram where the angles are congruent, like this, which we just mark with arcs, then the opposite sides are congruent. So isosceles triangle, you can start with the sides and go to the angles. You can start with the angles and go opposite to the sides. So like there's just this crisscrossy thing happening here. But the main thing is two or more sides are congruent. It also means that two or more angles are congruent. So it's kind of like a sub property to this, like it's the second property. So I'm going to put two or more angles, and this is just the angle symbol. It's like the angles with an S in it. Angles are congruent, because if two or more angles are congruent, just like I said, if the angles are congruent here, then I can go opposites and say, oh, well, those sides are congruent. Well, that's the definition of isosceles triangles, that at least two sides are congruent. So I can kind of go backwards from the angles to the sides. Okay, equilateral. So we also have equilateral triangle. So, and this equa, if we break it down into its root words, equa means equal. Lateral is talking about the sides. So this means that all three, I'm just going to put all sides, because we can say something is equilateral that's not a triangle. We're talking about triangles specifically here, but the word equilateral just means equal sides. So all sides are congruent. That's the basic definition of equilateral. Now, what we just learned about, and try to draw that a little better. Something like that. So we just learned about an isosceles triangle. If these two sides are congruent, then the opposite angles are also congruent. Now, if the third side is congruent, so I have 1, 2, 3, I have one tick mark, one tick mark, one tick mark. That's showing me that all three are congruent. I can do the same thing. I can go opposite to this angle. So that would mean that all the angles are also congruent. So if you have an equilateral triangle, then you also have what we call, and I'm going to get rid of, whoops, these notes. No, come back. Okay. Then we also have what's called an equiangular. And I don't know why I was going to put a capital A there. Angular triangle. And that just means that all angles are congruent. So remember, if it's equilateral, it's also equiangular. If it's equiangular, it is also equilateral, because if I know that all three angles are congruent, which we would mark with just one arc each, I can go to the opposite sides like this. And all of these sides have to be congruent because all the angles are congruent. So it would create this same length here each time, because the angle is the same and the length of the side. So the distance that the rays are going is the same no matter which angle I look at. So that means the distance between them also ends up being the same. It's just kind of one of those relationships that's nice to know. So these are the three things, or actually really four things, because this one has two, that we need to remember in order to do this topic. So for this first one, it says find the measure of angle Q. So then we're given 30 down here, and it says 8 and 8. So I'm going to draw this. I'll draw it in a different color here so you know I'm talking about this example here. And we have Q, S, R. This is 30 degrees. And then they tell us this is 8 and 8. So they're not using congruent marks, but they tell us it's 8 and 8. So it's just as good as congruent marks. We know that they're congruent. 8 equals 8. So if I know the sides are congruent, that was one of the things that we know. If we know that the two sides are congruent, we can go to the opposite angles here like this. So I know that angle Q and S have to be the same. But what are they? Well, this also goes into the triangle angle sum theorem, which just means that all the angles have to add up to 180 degrees. So that's always true. We've practiced this many, many times over the last couple weeks with topics. All angles of a triangle have to add up to 180 degrees. So if I know all three of these have to add up to 180, and I'm already using 30 down here, I'm going to subtract 30. And I'm left with 150 degrees. So now what we need to do is we know that these two are equal. If they're equal, I'm going to cut this in half by dividing by 2. So I get, let's see, 7 and 5. So I get 75. A little bit of mental math there. But if you don't know that off the top of your head, you can always write it out like this and work it out, or you can use a calculator. I just did a little bit of mental math. I know 2 can go into 14 7 times, and that would leave me with a 1 here. So 1 and a 0, 2 can go into 10 5 times. So I just did it mentally really quick. I got 75. So we know that angle Q has to be 75, so we come over here and we type 75 degrees in. Now we have to do this other angle. Oh, I want a bigger eraser there. That's going to take me too long. All right, a little faster if I have a bigger eraser. Okay, so this other one, we have this triangle. It's kind of right side up this time, and it's showing us these 3 tick marks. Remember, that means that it's equilateral because all 3 are marked with 1 tick mark. Now, if I went like this, that's not equilateral anymore. That means that 2 and 2. So the 2's go together. 1, it wouldn't even be marked because it's not equal to anything. So we actually wouldn't have a mark here at all. But I'm just trying to make the point that make sure you match it up. So 1 tick mark to 1 tick mark to 1 tick mark. That means that they all equal each other. And then we have P, N, M. And they want us to find M. So again, we need to go to the triangle angle sum theorem. And I think I may write that up here too before we go to the next screen, because that's definitely one we have to use. They all have to add up to 180 degrees. And remember, if all the sides are equal, then I can go to all these opposite angles, and they all have to be equal. So all 3 angles have to be the same. So I'm just going to take this 180 degrees, and I'm going to divide it up into 3 pieces, and I get 60. So, and this is true of any equilateral triangles. Once you know this, you should be able to easily remember that all equilateral triangles have angles that are 60 degrees. That little bit of information can make things a bit faster too. Oops, I did not want to erase my notes there. I'm going to go a little slower. There we go. Whoop. Okay. So I'm going to go here, and then I'm going to add, let's see. Let's go back to pink here. So this, I'm going to add all angles of a triangle are 60 degrees. So I put all angles are congruent, all sides are congruent, because this is open to every shape. But we're specifically talking about triangles in this topic. So for an equilateral triangle, all 3 sides are congruent. For an equiangular triangle, all 3 angles are congruent. So if you're talking about a triangle, all angles of a triangle are 60 degrees. So if you change it up to an equilateral hexagon, something like that, well, that would mean that it's 6 different sides. So we wouldn't have 60 degrees each. It would actually change it. So that's why I specifically put triangle on this one. Okay. And then we have the triangle angle sum. which just means the three angles of a triangle add up to 180, and I'm kind of taking up a lot of space there. We should be able to do all of our work down here. It's not going to have a whole lot of work on this one. All right, so let's go ahead and get started so we can get through this one. Okay, and change this up to blue. So this first triangle, and draw it down here, and we have this, and then they show us H, G, I, and we have angle, arc, angle, arc, angle, arc. So one arc to one arc to one arc. This tells us it's under this equilateral. Remember, angles are marked with arcs, and if we have 1 to 1 to 1, that means they're all the same. That's how they mark that they are congruent. So then they also tell us that this one is 4. So remember, if it's an equiangular, then we can go opposite sides like this. All the sides also have to be the same. So I know this side is 4 and this side is 4. So HI, which was the right side there, we just marked as 4. All right, let's see. Can I just going to click undo a few times here. Okay. So now we have this triangle here. We have L, J, and K. And then we get 9, 9, 40 degrees. Okay, and they want us to find, which is right here, angle K. So if we know that this is 9 and this is 9, even though they don't give us these tick marks, 9 is equal to 9. So I know if I go opposite, I have 40 degrees. If I go opposite, I have another 40 degrees. So these have to be the same. Sorry, it's a very ugly 40 degrees. But we want this angle here. What do they all have to add up to? 180 degrees. So I'm going to take 180 and I'm going to subtract the 40 and the 40 that I have. I'm just going to put the two 40s together. So I'm going to subtract 80 once instead of 40 and then 40 again. So I end up with 100 degrees. So angle K has to be 100 degrees. So let's go ahead and check this. Yay! All right. Let's go here. Let me try to erase this nice and slowly so I don't get my notes here. Okay, close enough. All right, so let's go to our next one. Okay, so we have U, and I'm not drawing this terribly great here. Probably going to have to do undo on that one because I went way too close. All right, so we have UVT for this triangle, and it's also telling us 12, 12, 12. So even though I don't see these tick marks, 12 is equal to 12 is equal to 12. They're all the same, which tells me that it's an equiangular, sorry, underline the wrong one, equilateral triangle because these are the sides. So equilateral. Equilateral triangles are also, drawing on my lines here, equiangular because I can go to all the opposite angles. So I know it's equilateral, and that makes it equiangular. If I want to know any one of an equilateral angle on a triangle, I just have to remember, and I'm going to move this down because it's in the way of my notes here. Remember this little piece here. All angles of a triangle are 60. And remember, this one went with equiangular. That's why it's right underneath it. So all angles of a equiangular triangle are 60. I probably should have wrote equiangular in here just so you don't mix that up. It's not all angles all the time. It's only under this equiangular bit. That's why it's kind of a little star sub property there. So I already know all the angles of an equiangular triangle are 60 degrees. I don't even have to do the math again. I remember the math was that they have to add up to 180. They're all the same, so I'm just going to divide by 3, and that's how I got 60 degrees. So if you forget this bit of information, hopefully you still remember that they have to add up to 180 degrees. There's 3 equal angles. Sorry, I'm getting my words all mixed up there. And I just divide by 3. All right, so let's go ahead and undo that so we can draw our next one. Not draw it so close to my notes so I can erase. All right, so we have this little guy here. And again, it's not necessarily important that you draw it the exact same way that they draw it. You should try to draw it close, but it doesn't have to be perfect. It's more just so that I can mark on it. All right, so we get these little marks here. So I know right away that this is an isosceles triangle, which right away I can start applying these rules of opposite angles. So if y is 50, then that also tells me that w has to be 50 because it's opposite the two isosceles, or the two congruent sides of an isosceles triangle. But they want to know x. So we're going to go back to the triangle angle sum rule. They have to add up to 180 degrees. I'm going to subtract what I have. I have 50 and 50, which is 100. So I'm left with 80 degrees. So this has to be 80 degrees. And I'm going to check. Yay! All right, one more of these. I'm going to bring this back up for a minute, and then I'll close it. Oh, I erased my 180 just a little there, but it's okay. Oh, it'd help if I clicked on the marker. Okay. So I guess I can leave that there. It's not really hurting anything. All right, so we have something like this. E, 110, F, D, and then they also give us these congruent tick marks. So I know they're congruent. So right away, I can start applying the rules. I know angle D is going to be congruent to angle F. And again, what do they all add up to? 180. So if I know they all add up to 180, I'm going to subtract what I have. And I'm left with 70 degrees there. Now remember, I have to divide this evenly between F and D. So I need to divide it by 2, and I get 35. So angle F has to be 35 degrees. All right, so I'm just going to go like this and draw this next one right here since it's our last one. And I have 60, 60, and 60. And then B, C, A. And they also tell me that this is 3 for this length here. Sorry, the C was a little low. All right, so if you remember this little rule that I wrote, kind of the sub-rule for equiangular triangles, all the angles of a triangle are 60 degrees for an equiangular triangle. Well, I see 60, 60, 60. So if I know that that's the rule for an equiangular triangle, then I already know this is an equiangular triangle. I can also just say, oh, all 3 angles are the same, so that must make it equiangular. If it's equiangular, remember I can go to all these opposite sides here, and they all must be equal. Because if it's equiangular, it's equilateral. If it's equilateral, it's equiangular. They're kind of interchangeable there. Once you know it's one of them, it has to be the other. So if this side is 3, then all the sides are 3. So I'm just going to go over here and type 3 and check. And we're done. Yay!